Okay, so looking at homogeneous differential equations of second order, and now for homogeneous equations of second degree, okay, we're going to look at ending up with a couple of constants in the solution. And now for what we have with 2y double prime minus 3y prime is equal to 0, if I put what I have in terms of what is referred to as the characteristic root equation, and so going from the primes in y to the order algebraically for what we have in R, so you got 2y double prime, and if I put this in terms of the characteristic root equation R, so we have 2r squared minus, okay, and corresponding to 3y prime, so you have a first order derivative, and this will translate to a first order variable in R, so you have 2r squared minus 3r is equal to 0. And looking at factoring, okay, so the greatest common factor between the terms is going to be r, and so we have r times the quantity of 2r minus 3 is equal to 0, and we have with the zero product property, okay, we can say we have that r is equal to 0, and upon setting 2r minus 3 equal to 0, so you have 2r is equal to 3, and ultimately we end up with r equal to 3/2. And we'll say that 0 will be the first root, 3/2 will be the second, but it could be the other way around. And for the general solution, we have that y of x is equal to c sub 1 times e to the 0x, and e to the 0 is equal to 1, so we have c sub 1 plus c sub 2 times e raised to the 3/2 of x. And that will be the outcome. For what we have in the case of the next homogeneous second order differential equation, okay, so you have 2y double prime minus 7y prime plus 3y is equal to 0. And if I translate in terms of the characteristic root equation, so we're going to have 2r squared minus 7 times r, and notice we don't have a derivative. We have just 3y, and anytime we have just the variable y but no order of the derivative, like change in y with respect to change in x or with respect to t, okay, well, in the characteristic root equation, that is just going to be the coefficient of the y term. So we have plus 3. And we have with this trinomial, we can factor. So we have with 2r squared, so this will go to 2r and r. And looking at the necessary factors of 3, whereupon the outside, the inside products will FOIL out to negative 7r once combined. Okay, so we're going to have 2r and r. So we have 2r, and it looks like that is going to be minus 1 times the quantity of r minus 3 is equal to 0. And if we set each of the factors to 0, so we have a 2r minus 1 is equal to 0, and if I add 1 and divide by 2, so we will have the r is equal to 1/2, and for r minus 3 is equal to 0, add 3, so we have the r is equal to 3. And again, one or the other could be the first root, and we'll just say that 1/2 will be the first, and thus we will have 3 to be the second. And so we have in the solution for y of x, okay, this is going to be c sub 1 times e to the 1/2 x plus c sub 2 times e raised to the 3x. And notice we have two distinct constants. Okay, now for what we have with this homogeneous equation, and this is going to be fourth order, where we have 5 times the fourth order derivative of y with respect to x plus 3 times the third order derivative is equal to 0. And if I rewrite what I have in terms of the characteristic root equation, so I'm going to have 5r to the fourth plus 3r cubed is equal to 0. And looking at factoring out, you notice we have greatest common factor is going to be r cubed. Then we have times the quantity of 5r plus 3 is equal to 0. And just to spread this on out, okay, so you have r to the third, so you're going to have a repeating root. R cubed, you have like r times r times r times the quantity 5r plus 3 is equal to 0. And again, you don't have to write raised powers, the monomial, in terms of multiplying repeatedly, but just want to stress something. Okay, we have just from r, okay, you have is equal to 0. And from 5r plus 3, setting that equal to 0, okay, so we have the r comes out to negative 3/5. And I will mention, okay, so if you notice we have r cubed, you have r times r times r. So you had the factor r to repeat twice. And that means that for what we're going to have, for r, you're going to have a repeating root. So essentially, we could say that r sub 1 repeating twice is equal to r sub 2 is equal to r sub 3 is equal to 0. And with r distinctively at negative 3/5, we'll just call this r sub 4. And writing out what we have in the solution. So we have y of x. And signifying that we have 0 to repeat. Okay, so you're going to have c sub 1. Okay, e to the 0. And for each repetition, you're going to add a monomial in the independent variable. So you have c sub 2 x. And then for any additional repetition, you're going to attach to the constant an even higher order, going up one at a time with each repetition. So no repeat, you have just the constant. One repetition, you have x to the first. Next, you have x to the second. And if I had r sub 4 equal to 0, I would have c sub 4 times x cubed. And then we have, finally, we have c sub 4 times e to the negative 3/5 of x. And again, this is a fourth order differential equation, and so we have 4 constants laid out. And so that will be the solution of what we have in the case of y of x. Now we have the second order homogeneous equation, and we have y of 0 is equal to 7, and y prime of 0 is equal to 11. And if we look at the general solution, first of all, okay, so translating this equation along the lines of the characteristic root equation. So we have r squared minus 4r, and again, any just of what we have with just a y term but no derivative, that is going to translate to a constant. And here we have a factorable trinomial expression. And factors of 3 that will add up to negative 4. We're going to have, again, the order does not matter, but we have r minus 1 and r minus 3. If r minus 1 is equal to 0, okay, we have the r equals 1. If r minus 3 equals 0, of course, we have the r is equal to 3. And I would just designate these respectively as R sub 1 and R sub 2. So we have with the general solution, we have that y of x is equal to c sub 1 times e to the 1x. And we have plus c sub 2 times e raised to the 3x. And we want to find out specifically what the constants are going to end up becoming. Okay, so we're involving, okay, y of 0 is equal to 7, and also y prime of 0 is equal to 11. Okay, so in creating a pathway to determining the values of c sub 1 and c sub 2, okay, so we have y of x, c sub 1 e to the x plus c sub 2 e to the 3x. And if I take the first order derivative of this expression, so I'm going to have c sub 1 e to the x, and first order derivative, now we're going to have 3 c sub 2 times e to the 3x. And since we're trying to solve for c sub 1 and c sub 2, do not change 3c sub 2 to a different letter like alpha or a or another c. And now we have, in terms of the initial conditions, again we have y naught is equal to 7, y prime naught is equal to 11. So looking at what we have in the development, okay, so you have y naught is equal to 7, y prime naught equals 11, and just transferring what we have here. So again, so when x is 0, okay, y is at 7, we have c sub 1 times e to the 0, so that is limited to c sub 1. And we have c sub 2 times e to the 0, which is c sub 2. And from the first order derivative of y of x, okay, so we have 11, and when x is 0, we have c sub 1 plus 3 times c sub 2. Notice we have a system of equations, and we can set up simultaneously. Again, we have c sub 1 plus c sub 2 is equal to 7, and c sub 1 plus 3 c sub 2 is equal to 11. And here I can eliminate one variable and solve for the other. And I think what I would do here is just eliminate c sub 1. So I can just take the negative of the first equation, and we have in the rewrite, so we have negative c sub 1 minus c sub 2 is equal to negative 7, and keeping the second equation the same, and with the addition method, okay, so negative and positive c sub 1 will go out, and we have negative c sub 2 plus 3 c sub 2, that will be 2 times c sub 2. Negative 7 plus 11 is 4, and we have with division by 2, we have that c sub 2 is equal to 2, and I can plug 2 for c sub 2 into either equation, and we'll just go with the first one. So you have c sub 1 plus 2 from c sub 2 is equal to 7, and right away we have that c sub 1 is equal to 5. And again, you can always go back and check. 5 plus 3 times 2 is 11. 5 plus 2 is 7. And going back to what we had with the general solution, and we have with y of x equal to c sub 1 e to the x plus c sub 2 e to the 3x, and satisfying the initial conditions we just worked with, we're going to end up with y of x is equal to 5 times e to the x plus 2 times e to the 3x. And that is the final result. Okay, for this homogeneous differential equation, okay, so we've got 9y double prime plus 6y prime plus 4y is equal to 0. And we have y naught is equal to 3. And y prime of 0 is equal to 4. So we have another homogeneous second order differential equation. And if I take what I have and translate in terms of the characteristic root equation, and it's going to turn out that we're going to have a square trinomial. So 9r squared plus 6r plus 4 is going to be 3r plus 2 times itself. And so we're going to have repeating once. So you have 3r plus 2 is equal to 0. And from this, okay, we're going to have that r of 1. And since we have r of 1 to repeat, we'll just say that we have r of 2 will signify the repetition. And if 3r plus 2 is equal to 0, we have that the root is equal to negative 2/3. So we have for the general solution, we have that y of x is equal to c sub 1 times e to the negative 2/3 of x. And then we'll have plus c sub 2 x times e to the negative 2/3 of x. And this is going to be the general solution. But now we're going to be looking at determining just what the values of c sub 1 and c sub 2 are. So carrying over what we have now. Okay, so we have y of x, you have c sub 1 e to the negative 2/3 of x plus c sub 2 x times e to the negative 2/3 of x, and just taking the first order derivative. Okay, so we have, again, first order derivative, so this is going to be negative 2/3 c sub 1 times e to the negative 2/3 of x. Now for c sub 2 xe to the negative 2/3 of x, we're going to have the product rule. And let's say that if I have c sub 2 x e to the negative 2/3 of x, we're going to say c sub 2 e to the negative 2/3 of x times the derivative of x. So we have c sub 2 times e to the negative 2/3 of x. And then we have trading places. Okay, so we have c sub 2x times the derivative of e to the negative 2/3 of x. So we're going to have minus 2/3 of c sub 2 times x times e to the negative 2/3 of x. And for what we have with the initial conditions, again, we have that y naught is equal to 3. And y prime naught is equal to 4. And carrying over to what we have now. So you got y is at 3 whenever x is at 0. And guess what? We're going to have that 3 is equal to c sub 1 because c sub 2 times 0 is going to be negligible. And for y prime naught is equal to 4. Guess what? Okay, so we have negative 2/3 of c sub 1 times e to the 0. And so we can just say we have negative 2/3 times 3 and we have plus c sub 2 times e to the 0. Guess what? So we have 4 is going to be equal to negative 2 plus c sub 2. And from this, okay, we have that c sub 2 equals 6. And so we're going to have, for the solution, going from the general to the specific, that will satisfy the given initial conditions. Okay, so with c sub 1 at 3 and c sub 2 at 6, it's going to turn out that we have y of x is equal to 3 times e to the negative 2/3 of x plus 6x times e to the negative 2/3 of x. And that will be the final result.